Okay, two things today. One is we're going to delve into shader code, which means we're going to go and look at some alternate websites which have shaders, and we're going to look at how you might go around taking one of those shaders that don't work with xLights and convert it across so that it does work with xLights, potentially change the shader somewhat so that it's more effective on the very low resolution props that we tend to put them onto. But let's start with shaders. And the challenge with shaders is you can spend a hell of a lot of time playing with shaders. It can become something that you spend literally hours and hours on as you try to get certain shaders to work. And most shaders, but not all shaders, can be ported across to work with xLights. The ISF website, which is the format that xLights is largely compatible with, is fairly easy to bring in, and a number of people have done videos where they've taken shaders from the ISF website and downloaded them and managed to get them running in xLights with very little change. We're going to be a little bit more adventurous. We're going to explore some other shader websites which aren't as easy to bring in, but give you an idea about it and teach you a little bit about how to configure them and change them, because some of those aren't inherently possible. The shader format that we use is defined by the ISF website, and there's a couple of links here. Most of them are chopped off, or some of them are chopped off. We'll orientate it. And I would encourage you to take a little bit of look at, particularly at this ISF spec, which I think it's not that one. I have so many documents open here. This spec here, which talks through the ISF format. It talks about a number of constants that are defined, and not all of this is true in xLights, but a large amount of it is true in xLights. xLights doesn't support things like multiple pass shaders, and it's got some limitations on the bringing in of images and audio and the like. And you don't need to read this right now, but we will come back to this. But this is a bit of a reference document that you may want to look at some point as you get more into it to understand a little bit more about the format. The ISF website also has some broader documentation here. It does particularly talk about this header block here, which we will talk about in more detail, because this is how the parameterization of the shaders is done in xLights, and this is the format that is defined by the shader document format. If you want to get into, there's really two levels of shader development. One is you grab a shader from one of the websites that publishes shaders, and you can play with them. The other level is to start writing shaders from scratch, or beginning an understanding of how to code shaders. We're not going to do the latter. It's a little bit beyond me. There's a lot of math in shaders, a lot of matrix math, etc., which is all just a little bit beyond where I was at. It's also quite a different way to program. It's the way a shader program runs is not exactly like a normal program. Most programming is quite procedural. You break the problem down into a series of steps. You go through those steps. A shader doesn't run that way. A shader runs once for each pixel on the screen, and consequently it you've got to think about things very, very differently, and that's not something I necessarily am able to wrap my head around well. But fortunately, to do what we're going to do today, you don't have to be an expert in that. But if you watch some of these YouTube channels here, you may start to get an understanding of how they work, and you may at least be more comfortable with changing the shaders that you find, or potentially even get to the point where you can write your own. But there is translation required as you go from the various formats. Now, some of the websites that you can go out there and find shaders, obviously, we can get rid of that one, we can get rid of that one. This is the ISF website. This is part of it. The way my screen's orientated here, you're only seeing part of it. But this is the ISF website. There are literally hundreds of shaders here. You'll recognize some of these as being in xLights today. They are in xLights today. They're just literally, xLights just downloads them from this website. They don't necessarily require a great deal of conversion. Like I said, a couple of them won't work, but the vast majority of them probably will work just as is, unchanged in xLights. So that's not that interesting. So we're going to skip past those. This is a website called Shader Toy. Shader Toy has a large number of shaders. It has about 49,000 shaders according to their website. There's a lot of shaders on here that will never work with xLights. They're heavily dependent upon images and things that xLights just doesn't have the capability to bring in. But there's still a lot of shaders here that will be brought across. It's a very popular platform for people to develop and share shaders on. And so you may want to look at this website as a potential source of shaders, and we'll talk a little bit about that. Shader Frog is another one. Shader Frog, you have to sign up to access the source code of the shaders. It has a number of shaders on there that would potentially look quite interesting in xLights. Not every shader can come across. There's a bit of combinational type work of shaders in Shader Frog which is not supported, and there's a couple of weird things in Shader Frog. I'm not super keen on it, but yeah, you could absolutely take some of the shaders here and bring them across into xLights if you want. And then there's GLSL sandbox.com, which is where we're probably going to source our shader from today. This is quite a basic website. It's not necessarily easy to browse. It doesn't categorize things, etc. But it does have a lot of shaders, and a lot of them are going to be quite suitable to xLights. And so we're going to pick one up from here, I think, at least, and convert it and play with it. In fact, this is probably the one we will do, at least initially, and I'll resize my screen here in a second and we'll do it. Now, let me go through the presentation piece before we jump into that, and then we'll come back and we'll actually do some playing. Now, to convert a shader across to work with xLights, you need to do a number of different things, and you can play a lot with the shader first before you do all of this sort of stuff, but by the time we get there, you're going to have to do this to get it to work properly in xLights. And the first thing is you do need to put this header block on the top of the shader, which basically describes the shader to xLights. You know, you have the option to put the credit. Ideally, you would credit the original author of the shader if you're porting one across, rather than trying to claim credit for it. You can also put in a description of the shader, which will appear within, it appears in a tooltip, I think, within xLights. And then there's a section here where we will end up parameterizing it. This is where you will define all of the configuration parameters that the end user will want to be able to play with the shader once it's in xLights. What you will find is the vast majority of shaders outside of outside of ISF are not well parameterized. Everything is quite constant. So you look at the shader and it's just like watching a video file. But you can often parameterize them, and we'll talk about how you do that. This is a shader. This is probably the most basic shader that you could write. It has a main function which is called once per pixel on the screen. Fragment color is an output variable. It's a 4-parameter vector, which means it's just a value that has 4 components to it. And those components are a value between 0 and 1, and 0 being effectively off, and 1 being effectively fully on, and they represent the colors. So the first one is R, the second one is G, the third one is B, and the last one is the alpha channel. So red, green, blue, and transparency. And so this particular shader here, which we can write, will basically draw the screen red. That's all it does. And it's really as simple as that. And you notice that it has nothing in this about the number of pixels on the screen or anything, because it's run once per pixel. So every pixel runs this program and it comes back and says, set that pixel red. But obviously you want to get a lot more interesting than that. There are a number of variables or variables because they're passed into the shader each frame that renders, and these are going to be the key variables that differ across the various platforms that we need to align to what xLights is expecting so that xLights will work correctly with the shader. The first one, the ISF frag chord, that's a two-dimensional vector that represents the location of the pixel that is being rendered. Now it's an absolute number, and so people would typically convert that into a normalized coordinate of between 0 and 1. So 0, 0 is the bottom left-hand corner, and 1, 1 is the top right-hand corner, because most shaders work with those sorts of ranges. The render size variable is the actual size of the render buffer. Now in xLights that tends to be a relatively small render buffer, because if you're putting it onto a matrix panel, it might be 48 by 16 or 24 or something, and so it tends to be quite small. Whereas most of the shaders that you will see on the various websites are expecting to render on a screen that's 800 by 600 or 1200 by 700 and odd pixels, etc. So the smallness of the screens or the buffers that we render on in xLights can often be a challenge for the shaders. The time variable is the current time of the frame being rendered, and this is a key variable because when you see time referenced in a shader, the shader is going to be a shader that probably moves and animates. If there is no reference to time inside the shader, it's typically very static. And so if you see a static shader that just displays an image, but you want it to do things over time, you'll want to introduce the time variable into it somewhere to change color over time, or change position over time, or to change the way in which the screen is distorted, or whatever else over time. Time delta and frame index are much less common. Time delta represents the amount of time that elapses between each frame, which is going to be, in our case, typically 25 or 50 milliseconds. And the frame index is just the index of the frame. So the first frame is frame 0, then frame 1, and so forth. Again, these aren't really commonly referenced in the shader source that we'll look at, but if they are, you can access it and convert it. xLights also builds in a number of functions that you can access, and they're listed here on the next several screens. We're not going to go into them in any great detail. Most of these are used for sampling colors from another image, and so xLights has the ability for a shader to pick up the underlying layer underneath the shader and apply transformations to it. And so think of things like the warp effect and the kaleidoscope effect. You can do similar things with shaders, where the shader picks up the underlying layer and then transforms it in a certain way. And so you may end up using these functions as helper functions in that case. Some of these are also used to replace some functions that might exist in some other shaders which xLights doesn't support. And so there's a bunch of these things defined here, and I'm not going to spend any great deal of time on it. In order to parameterize the shader and allow the end user to change the values that the shader sees, we need to be able to define variables. And there is a number of different variables, and these variables turn into sliders and combo boxes and checkboxes in the xLights user interface. And so the first one, and probably the most common one, is a floating point variable. It has a minimum and a maximum, a default, which is typically the default value. I typically use the value that the shader has on the website, but you may choose to actually change that default value to be something that's more likely to work on the types of resolutions that we use in xLights. The variable name is the name that particular parameter will be referenced by inside the source code, and the label is the name that the variable will have on the screen that the end user will interact with. And I would encourage you to make that a little bit more human understandable as to exactly what that particular variable does, rather than just use the variable name itself. These are floating point numbers. You'll find that shaders generally don't like integers. Most variables are floating point numbers. The shaders themselves do run on your video card and run using largely floating point values. The second variable type is the color. Now the color is mapped to the xLights color panel. So the first color on the xLights color panel will be basically mapped in the order in which you put it in there. So you can have multiple of these parameters inside the JSON file that you then reference inside the shader, but they will be mapped to the color panel in xLights, allowing the user to choose which color the shader uses in certain scenarios. Most shaders don't use this. Most shaders generate their colors internally using mathematics, but they can pull at least some basis of the color from xLights if you wanted to, and you would use one of these color variables to do that. As I said before, the values are defined in the range 0 to 1, not 0 to 255, so you have to get used to that.
Keith, how many colors can we pull from xLights? There's the 8 on the color panel that you can tick off, but you also have that hue bit at the bottom.
Yeah, the hue is applied after the shader renders. The hue is applied to all colors in the effect. So the 8 colors are drawn from xLights, the shader is rendered, and then the hue shift is applied onto the shader after it's rendered. Point 2D, so some shaders you will see references to a mouse, and if you will use them on the various shader websites, you'll find that you can interact with the shader by either just dragging the mouse across the shader, or sometimes you need to point and click at the shader, and the shader will distort in some way or react to the mouse in some way. These are typically represented as these point 2Ds. In xLights, it will be represented as an X and a Y slider, which you can then put a value curve on if you want to. But that's how these are typically represented. We don't have a simple way to represent the mouse in an xLights render. Audio FFT will pass in the audio frequency spectrum breakdown of the audio, and so you can have shaders which are audio sensitive. Some shaders expect the audio FFT, some shaders expect the audio. As Tony was discussing earlier, the audio ones aren't supported in xLights at this time. I definitely think we should, it hasn't been implemented. Booleans, if a shader calls on a Boolean parameter, this will be displayed as a checkbox to the user, and this allows the user to turn an option on or off within the shader. Long variables, these are less common, but you can have, basically this is a combo box. So if you're going to have a number of different absolute values that you want the user to be able to set, you can represent those using these long values, and they're displayed inside a combo box where the user chooses one of the values. This is not like an integer parameter where you can define any number. You typically use a float for one of those. This is used for a limited set of possible values. And an event. These are very uncommon. I think Tony mentioned this the other day. The only place he's seen this used was in the lightning shader in xLights. This enables you to effectively you trigger an event in the shader and it's picked up in the shader. the shader does something when that event occurs, and those events are tied to a timing track inside xLights, and so whenever that timing track has a timing mark, the event will be sent to the shader, and the shader will do whatever it is that the shader does in that scenario. And then we have the image parameter, and the image parameter is how you access the underlying layer underneath the shader. Shaders that use the image parameter will typically have their canvas mode turned on, which gives them access to that underlying layer data from the shader. And that's it. Then there's a couple of things here, which is some of the conversion parameters, and we're going to reference these as we dive into a shader in just a minute. And so if you ever see a reference to something like a text2D function, you'll probably want to replace it with this function here, and we'll come back to this, and then a text2D rectangle where you replace it with this function here. When you choose a shader, you want to choose a shader that has large blocks of color. You don't want a huge amount of fine detail unless it's possible to zoom in on the shader, and the reason for that is things which have lots of fine detail don't generally look good in xLights. xLights, just due to the lack of resolution, those sorts of things don't look good. And obviously movement. Generally you want to have some sort of movement in the shader that you're bringing in, or at least be comfortable adding the movement to the shader. The only time that a shader with no movement, I can't think of a reason why you'd use a shader if you've got no movement. You may as well at that point just put it into an image file and use it in xLights as an image. Converting the shaders, and we're going to go and do this in a minute. Use the online sites. Definitely explore the constants inside the shader, and we'll do a bit of this where you want to understand what each constant is doing to work out which constants are interesting. You'll want to get familiar with the xLights log file, because when xLights is using your shader, if there are any errors around using the shader, all of the errors are placed into the log file, and so you want to go into the log file and look at the log file to understand why the shader's not working. It also lets you see how xLights manipulates your shader to compile it, and so you can see a little bit behind the curtain as to what xLights is doing. Definitely concentrate on getting it to work first before you spend a great deal of time customizing and configuring it. You don't want to invest a huge amount of time in a shader only to find out later that it will never work in xLights, because it depends upon something that xLights doesn't support. And once you've got that working, then you can start exploring adding the JSON and getting the inputs, etc. Making sure that all the variables are renamed, and rename the main function and all that sort of stuff, and then introduce the variables. And we'll do all of that in a minute. A couple of websites that you might want to look at: GLSL Shadebox, ShaderToy, and ShaderFrog, along with the ISF website. Explore and see if you can find things. And this is a bit of a cheat sheet for people that are doing the conversion. The parameters that we talked about, so we talked about the time parameter in xLights, which ISF also uses, but you'll see that on the other websites it's got a slightly different name. We are going to need to address this, and so this is a table that you will probably want to come back to at some point. Grab a screenshot of it out of the video or something, because you'll want to access it. The render size is the size of the screen. Again, it's got slightly different names in the other shaders. The fragment coordinate is the coordinate of the pixel that's being rendered. Again, different names. The normalized coordinate is the same thing, except it's a value between 0 and 1. We talked about the time delta and the fragment index. I didn't necessarily find parameters. It doesn't mean that these shaders over here don't support those parameters. Just in my research, I didn't come across one, so I didn't note its name. And fragment color is the output color of the pixel, and again this has slightly different names on each of the platforms, and we will need to rename these things. And some of them have mouse support, and this I channel 0 to 3 on ShaderToy is how it accesses underlying images. and the like, which we don't, we use the parameters in xLights. And I think that was all I had as a presentation. Let's go in, and we are going to, in our discussion, I'm going to resize this so that you can see the whole thing. We're going to play with this shader here and try to bring this shader into xLights. Now, Tony quite generously has already verified that it works in xLights, so we won't do that. So what we are going to do, however, is... Oh, it's interesting. There's another interesting website there. I wonder whether this website's got more shaders on it as well. All right, so what we're going to do is we're going to play with this a little before we start bringing it into xLights. So the first thing I'd like to do is understand how can we change this thing, and what do all of these things here do? So we can see from the top here that this is accessing the resolution and the time. So that tells us the resolution is the screen size and the time is the animation, which is why it's moving. If I was to find the time variable in here, where's the time variable? Oh, it's a little bit further, it goes further. There it is, there's the time variable there. So if I was to take that time variable and make that a 1, it doesn't like integers, it likes constants. Okay, that didn't stop the movement. Where else is there a time variable here? Okay, there's a time variable here. If I was to make that 1.0, did it stop moving? It did not. It references the time variable a lot. All right. Well, let's not worry about that. There's actually quite a lot to this shader. Okay, so let's clean this thing up a little bit. Let's get rid of all these comments because they don't do anything, and so they're just cluttering up the code that we're looking at. This here is setting the color, and so playing with the parameter. Now, the way I like to experiment with playing with the parameters is typically change the order of magnitude. So if I was to let's change this by 2 orders of magnitude, you can see that the shader has become a lot more grainy rather than smooth. So that's probably not a parameter that's particularly useful to change. This one here, similarly, it made it a lot more grainy. Again, probably not something that's useful to change. Let's try changing this. Okay, that made it a lot dimmer. Again, maybe not something that I want to spend a great deal of time changing. Let's come up to these ones here, this beam direction. All right, what happens if we make that 0.9? Okay, well that's interesting. It kind of moved it across a little bit. What if I make that 1? What does that do? That didn't do anything interesting. The time here is probably going to change the speed in some way. So if I set that to 1.2, again, it's not making a huge amount of difference. We are not seeing a lot of difference here. Sometimes you might want to actually multiply the whole thing. Wait. This shader is very resilient to change. Alright, let's go up here. Let's change. Oh, that made a difference. In fact, that made it a lot more colourful, potentially. Let's go extreme. Well, that's not so good. Let's go to 5. Also not great. So I don't know. I think this one here might be a parameter that's interesting, right? So this is, as we go up to 0.9, the colours become a bit deeper, right? I don't know, let's call this colour depth. So what we're going to do is we're going to come up to the top here and we're going to say const float color depth is equal to 0.5. All right, so we're just going to move that up as a parameter because we're going to come back later and play with that. All right, so here we've got some more constants. Didn't do anything interesting. Let's change this, make this 116. Yeah, it's not that interesting. 110. Not that interesting. Why is this 8? What's that going to do? Not a lot. All right, now we've got position. So positions often are interesting, but this one's not. Whoa, that changed the speed pretty dramatically, didn't it? So let's call this thing speed. Const float, if I can type, speed. All right, so that's the speed. Where were we? Color depth. We were here, speed. All right, let's try this one here. I don't think that was that convincing. Not that interesting. Okay.
Actually, maybe it makes it rotate a bit more, it seems like.
Oh, did it? Oh, yeah, so it did. Sorry, okay. Let's call it rotation. Thank you, I was beginning to wonder if everyone had left me.
We're all captivated here.
Are you? I'm sure you're not.
There's a few of those things that you changed that, wow, that does look cool. I found it just cool that you could just come in here and
play with it,
things around and see it right away.
Yeah. Well, this is the advantage of playing with them online. Here is you can see which things are going to make a difference. Now this value here, I don't think this was not making any difference, was it? We've already played with the rotation. I think we'll move on. Let's have a look at this one here. What happens with this one?
Just one thing I'm noticing is it's a lot easier to work with the shader here in its raw form than to port it into the ISF and then try there, because in ISF you have to re-upload every time you make a change.
All right. So this is definitely doing something. Oh, this is moving the line away, isn't it? So I actually think this one here is quite interesting. If I change it to 1, yeah. So I'm going to call this position, if I could spell. Pause. Why am I putting 2 S's in position? Okay. We at some point here we're going to just stop this because obviously every constant is potentially a parameter. So we'll leave it there for now. You can come back and play with this later if you'd like to add even more. All right. So we've played a little bit with the shader. We found some parameters which maybe we don't want to be constant. We would actually like the user to be able to play with. So let's now start to prepare this shader for xLights. And so the first thing that we need to do is take a copy of that code, and we need to go to something like a Notepad++. And we need to paste the code into Notepad++. Here it is here. And we will want to save it somewhere. So, oh, this will do here. We'll put it here. This is fragment shader, FS, because that's what xLights likes them to be called. Now we can start to prepare the shader for xLights. And so let's try in the first instance to do the minimum amount of change necessary to get it into xLights. And so there's a couple of things that we need to do. The first thing we need to do is to go and grab from our presentation here that header, this header here that we need to put at the top of each shader. And so we're going to do that. We will, whoops, where am I? I'm all over the place. Shaders, left, right, and center. This is the one we're playing with. Actually, it was in the code. What am I doing? It's down here. All right, we'll give credit to the original shader author up here, because we didn't write it, and I don't know. We're calling this file line or something, weren't we? This is the name we wanted to call it. Now we're going to get rid of this hash define thing here. That's not required in xLights, and we're going to the resolution. Now the easiest way to deal with these resolution and time variables is to use a hash define. And so what this is like a global search and replace. So everywhere that you find time, we're going to replace it with time, and everywhere that you find resolution, we're going to replace it with render size, because that's what xLights expects them to be called. And we can get rid of those now. And with any luck, that's the only change that we need to do. The main function looks fine. Some main functions on some of the sites will have extra parameters in here that we would need to remove. Oh, we will need to deal with the glfrag chord. So again, let's do a hash define for that as well. And does anyone remember what we needed to call it in xLights? Where's our conversion
table?
table?
You were using ISF, but xLights accepts the glfrag chord as well.
Yeah, I think you're right. I think behind the scenes we deal with that.
And same with the frag norm chord and frag color.
Right. But we can change these. Let's for the hell of it change them, because we can do this. So we can change that to be that, and actually maybe we can't. All right, we'll leave them as they are. All right, let's leave it like that. Let's save that shader, and let's go to xLights, and let's see what sort of layout have I got here. I've got a reasonable size grid, 50 by 16. Let's up that a little bit. Let's make it 100 by 50 just to get a bit of density. We'll save that. We'll create a new sequence. Let's grab our shader, bring it down. We'll browse, and we will grab our shader, which is not in that folder, but in that folder. There it is there. What do you know? It worked first time. What are the odds? Doesn't quite look the same, does it? But that's okay. All right, so our shader came in first time. Let's break our shader, just because I want you to see what happens, and you can't see it unless it breaks. So when it breaks, it comes up in yellow. And if you go and do a tools view log, And if you go to the end of the log file, you can see that it's got this error, failed to compile the shader program, and immediately prior to it is a full copy of the shader program that it was trying to compile. And most of this looks exactly like the code that you imported. The difference is at the top there's all these extra functions that have been added, so those functions that xLights introduced. And there's a whole bunch of variables here that have been defined, which is how xLights passes all of those values in. But even more important above that is the error code that the compiler failed on. And so it's telling us that on line 84, there was these DD characters that it didn't understand. And if we go back here, it turns out that line 84 is actually line 22, and we can save those. Now, if the shader compiles without error, there won't be anything in the log. So sometimes you just need to force it to error so you can go and see what's going on in the log file. But there's no parameters, right? Everything is constant. Despite all of that playing around we did with those parameters, nothing has actually appeared here. And the reason for that is we haven't told xLights about those parameters yet. And so to do that, we need to go back to our parameters here, and all of the values happen to be floating values, and so we're going to grab a copy of this thing here. We're going to go back to our shader, and in the input section here we need to add in our parameters like so. Now this is a JSON format. For those of you familiar with JSON, it's a very, very common data format, and we identified 4 variables that we're going to introduce. So let's add them in here. We'll spell color right for the first time in xLights. We're going to call it color depth just as we did below. So that's the variable. The value that they suggested was 0.5, so we're going to go with 0.5. Now, we didn't really test the total limits of this, so here's where you need to say to xLights, how much of a range of values do you want to support? We should probably go back to the shader website and experiment to see what range of values makes a difference so that we can work out what a good minimum and a maximum is. And we won't do this for all of them, but let's quickly go back to this, and we're looking at the color depth. So if I set this to 0, does it produce anything sensible? Yeah, it's not great, but it works. If I set this to 10, is that sensible? That's not really sensible, right? If I set it to 1, is that sensible? Yeah, that's not so bad. But it looks like once I get above 1, the whiteness starts to appear. So maybe between 0 and 1 is the right value range for this. So we'll set the maximum here to be 1. We can then copy this and add another one. Don't forget to put a comma after the first one. This is a list, and so you need to comma separate them. And we go down to our next one. So our next one is speed. Its name is speed. It's a floating point value. The default value is 32.0. You do need the point zeros. It needs the floating point. So let's have a quick look at our speed. So what's a speed of 0 do? Well, it still does something. What's a speed of 100 do? So 0 to 100 looks fine. What's minus 100 do? Oh, it goes the other way. So maybe we want to be able to support both. So shall we do minus 100 to 100? Minus 100 is our minimum and maximum's 100. Okay, let's go and add our next one. We'll get 2 more. Let's just add. Okay, so the next one, what was the next one? Rotation. It's a floating point value. Let's go back to it quickly. A rotation. Okay, so a rotation of 0, what's that do? Still rotates. Rotation of 100, what's that do? Whoa! That's a bit much, don't you think? 50 maybe?
That's more like speed of rotation rather than rotation.
Yeah, I know it is, but that's okay. 50 looks... Oh, that's interesting. And 0... So we're going 0 to 50. I think that'll do. Oh, rotation up here, sorry. So we're going from 0 and we're going to max this one out at 50. And the last one is position. A floating point number. This one's got a value of 2. And our position of 0 was nowhere, right? Sometimes it doesn't like zeros. Sometimes it isn't, doesn't. Okay, ooh. Not sure even 1 is great. You probably want it on the screen. Well, 5's a bit much. Maybe 1.1? Yeah, I think 1.1 might be our minimum. What's 100 do? Even that's not bad, is it? 50 is no different, so there's no need to go as high as that. 30 is no different either. So we're starting at 0.1. What's 10 do? Might want to go a little bit higher than that. Maybe to there. Maybe we'll go from 0.1 to 20. 0.1 to 20. And we're done. So we'll save that. We'll go back to xLights. We'll click on the effect. Okay. Didn't like that. What did we do wrong? Everything's a floating point number. Oh, I know what we did wrong. We've effectively double defined these things now, so we have to take those constants out. Now we'll click on it. Okay, so the thing's back, but we don't have any parameters. You might need to click off it. Sometimes you, and I think Tony showed this the other day, sometimes if you browse to another shader of some other type, and then come back, it will reload the parameters. Okay, so our parameters have now reloaded. It's just a matter of getting xLights into the mood to load the parameters. And so all of our parameters are there. Our color depth is doing what it does. Our speed, our rotation, and our position. Yeah, our position's working as you would expect. So I don't know, that's a great shader. We definitely need to maybe potentially find a zoom or etc. But that's essentially how you go about converting a shader from a non-compatible shader into a xLights compatible shader and parameterize it. Yeah, they do all become air. Everything that's a floating point value becomes adds a value curve, so you can change it over time as well.
Okay. I know there is a website that converts shader toy to ISF. Is there any chance that there would be a shader toy / ISF to xLights website?
Well, there already is from an ISF perspective. So xLights has already been written and there's a bunch of substitutions that go on the background to try and make the ISF ones work automatically in xLights. What we haven't done is gone and tried to make shader toys work automatically in xLights. The challenge you run into is we'd have to know what format it was in to start with, because I can't just go and replace every time variable with a time variable from xLights, because what happens if it was written and used the time variable, because on the ISF website the time variable doesn't exist, so you can quite happily use it within your shader. So you actually kind of need to know what format it's in. We chose to use the ISF format because the ISF format had all of that nice parameter description logic, and that's obviously something that we wanted in xLights because we wanted the effects to be parameterized. If the effects weren't parameterized, you may as well just turn them into movie files and do it there. Brent asks, can you use the ISF editor to download the shader and edit the variables for xLights? Yes, absolutely you can. I did it in the GLSL shader location because you can do it in real time and you guys can see how you work out what's happening. Everything that I did on the GLSL shader website, you could in theory have done in the text editor and just kept going back in and out of xLights to work out what was happening. It just takes a bit longer. And you've got to keep diving into log files to see why things fail, whereas on the website it's very quick to do, which is why I tend to do it there when I have to.